All right, so we're balancing a redox reaction in basic solution. And this means that when it comes to balancing for charge, we're going to use hydroxide ions. A quick reminder that I tend to write hydroxide ions this way, and that's because, as you'll see when you go on in chemistry, the negative charge is associated with the oxygen atom, but it essentially means the same as OH minus. Okay, so the first step is to determine the oxidation number of bromine and fluorine in the redox reaction. So this is shown down here. We see the oxidation number of bromine in these ions is +5 and +7. Fluorine here is in its elemental form, has an oxidation number of 0, and this is a monatomic ion. The oxidation number is equal to its charge. Now, before we worry about electrons, we want to take note of the coefficient here on the 2. We need to balance those atoms that are changing oxidation number before we worry about electrons. So we have 2 fluorine atoms on the reactants. We need 2 fluorine atoms in the products. Now we can go on and worry about the electrons. All right, so again, our rule is 1 electron per unit change in oxidation number. So if we look at bromine, all right, so we'll start by looking at bromine. Bromine goes from +5 up to +7. That's 2 units change of oxidation number. That's an oxidation by 2 electrons. All right, we look at fluorine. We see that we have 2 fluorine atoms, and each one is being reduced from 0 to -1. So each fluorine atom is accepting 1 electron, and we have, therefore, a total of 2 electrons that are being gained. So happy day. Already the number of electrons lost is equal to the number of electrons gained. We don't have to do anything with the coefficients because the number of electrons lost is equal to the number of electrons gained. Now we go on to worry about the charge, knowing that to balance the charge, we have to use hydroxides, something that is negatively charged. And here's our situation. We have 1 bromate, has a -1 charge. 1 fluorine has a 0 charge because it's a neutral compound. We have a net charge of -1 on the reactant side. On the product side, we have 1 per bromate ion and 2 fluoride ions for a net charge of -3. So as things are written now, we have a -1 in the reactants, a -3 in the products. Again, we're in basic solution, so what we have to balance the charge is hydroxides. So in order to balance the charge, we're going to have to add 2 hydroxides to the reactant side. And now we have a charge of -3 on each side of the equation. We are balanced for charge. The next step is to balance the oxygens with water. Looking at the oxygens, we have 2 oxygens from the hydroxide, 3 oxygens from the bromate ion, so a total of 5 oxygens on the reactant side. On the product side, we have 4 oxygens from the perbromate ion. So we need 1 more oxygen on the product side, which means we need 1 water molecule, and now our oxygens are balanced. If we've done everything right, our hydrogens will also balance. We have 2 hydrogens, we're good, we're done, we're balanced.